Tim thought you might have all been having a bit too much fun, so he scheduled me to come. Because this is the hard grind. Programming, I think, has an incredible power and beauty, but it's harder to access than fun animations as building bridges out of cards. Hang in there. The session before lunch on the last day is traditionally a hard slot. Please bear with me. There's me mostly, and then Michael wants some time at the end to talk to you about Code Avengers. So hang in there. You are going to get lunch, but you're going to suffer a bit first. I'm going to talk about the programming standard 3.46. I work with my colleague Sandy, who is my lab administrator and teacher for the first year programming paper that we run at Otago together. If any of you are getting our workbooks, Sandy does most of the work on those. If your schools have paid for those workbooks, then those wages pay Sandy's salary, because otherwise she'd work for free, and I don't want that to happen. So we ask schools for the money for the workbook. But if any school can't find $200 for a workbook, we can probably still. Anyway, yesterday I distributed a bit of a questionnaire. How did level 2 go? There were lots of responses. Many of them didn't really give me an impression of how it went, but of those that did, about 13 I would have put in the it went well, it was good category, 7 neutral or mixed plus and minus points, 2 clearly bad, and a whole bunch of others. I would have expected this weighting towards the it went well from a group of teachers who would come to this session. I suspect that the distribution might be a bit different if we were able to ask everybody in the country. But I pulled out a few comments out of this. The ones who thought it went well, great. I did Turtle graphics in Python, good. I converted Java into C# and it worked well. Lots of work, pretty good. Pass rate was good at the end. The people who found it easy are boring. The people who had problems made more challenging comments. Neutral and bad. The students complained that it was only 3 credits, saying they could get them much easier in any other subject. That was something that came back to me verbally as well. I certainly think it's true. These are 3 hard credits. That's why I'd always like to see the 2 standards done together as a unit for 6 credits. And I think even 6 credits, it's a lot of work for programming. Found it complicated and students struggled with it, but they started to get it at the end. Good. Students really struggled to grasp the language, but less than they didn't work very hard at doing so. I'm sure that's common. Students struggled, some opted for 2, 4, 5, I struggled, and most students gave up as a comment on one form. That teacher spoke to me, they don't have a class next year. It's not gone well for everybody, so wherever you sit on the spectrum, you're not alone. There are other teachers, I think, who've had similar experiences. There's a few themes I wanted to pull out. Time. Took a lot longer than I anticipated. Issues with methods and passing data between them. It took a lot longer than expected, so we ran into time issues, and this relates also, of course, to the workload was too heavy for 3 points. Marking. I expected these too. Marking was the biggest issue. It was hard to differentiate the grades. Students went well. Teacher trying to cope with the merit to excellence. Found it difficult marking between merit and excellence. Yeah. The standard of the frameworks boxes us in really tightly and not appropriately, I think, to programming. And I know the standard authors struggle with this at all stages of the standards. And what we've ended up with does try and make distinctions, and I think it is possible, but I also think it is difficult because the programs we're assessing are so small. The criteria there make sense, but they make sense for biggish programs, and it's maybe hard to make these calls in the smaller programs that we're actually dealing with, produced in the classroom. There's another point relating to that coming up too. Students who had done level 1 coped well, those that hadn't struggled, I'd expect that effect to be even more exaggerated in the transition from level 2 to level 3. I think you'd be really struggling to try level 3 if you haven't done level 2. Most students who reached above achieved level were able to advance their understanding to excellence level. This also would not surprise me. Introductory programming courses at universities around the world over decades have unusual distributions of grades. Lots of students fail or drop out, but also lots of students get A's, A+, and do really well. There's less in the middle. It's almost the opposite of a bell curve sometimes, depending on how you process it. It's the empty bell. lots of possible reasons for that, but if you find that your class is distributed and you're finding it hard to spot the merit ones, well, maybe that's appropriate. Maybe there are the achieved and the excellence with less in between than you would expect in other subjects. 246 results better than 245, planning very weak for 50% of candidates. Got a lot of comment about that verbally too. They wrote good programs but their plans weren't up to scratch. And programming a standard is more coherent than planning, or the assessment of it is. Perhaps they should be a single standard as at level 3. This was again a debate internally as the standards were being developed. I'm in the camp that thinks they should be one standard at level 1, 2 and 3. That may be reviewed at sometimes. Others think it's the split works perfectly well. It's up to everybody to decide. I think that's all the notes I've got. Any sort of comments or responses people want to make to the group about all this? I mean, we've been through level 2. What was it like? No? We'll let those comments speak for themselves? All right. You are not alone. Level 3 then. Next year. It follows on from 2 3-point standards, 245 plan and 246 program. And they've been amalgamated together into 346 developed, which was a word that tried to capture aspects of both plan and program. The emphasis we expect would be on the program. And it's now fortunately 6 points. I would like to see it more, but apparently that would be a real struggle. I would say it's extremely difficult, if not impossible, to take on 346 if you didn't do 246 in a text-based language such as Java or Python. I really think you'd have a hard job going there. I should say, now that we've moved on to this, that these slides are a summary of this more extensive document, which is also available at that link there. This is my home page, CS Otago ACNZ, staff, crew, staff, private, Anthony, cs4hs.html. There's a web page there with the various resources, including this one. You can bring up the PDF of the handout that you're getting. You can bring up that PDF and see it. Parts of it are easier to view if you can see them in colour. So, slides are the abstract, the paper's the details, and the PDF might be the most convenient way of looking at it. Okay, so that's the context, that's where we're coming from. What's old and what's new in this standard? The reassuring thing, I think, is that there is everything that you did at level 2 carries over and remains relevant at level 3. None of it gets thrown away. All the stuff about good modular design and scoping things properly, good procedural design, robustness and flexibility, clear, well-commented code, systematic testing and so on, all of that carries straight over and remains relevant. The language has had to compress it in the standard, the language has had to sort of compress the level 2 stuff, but it's all still there. The only stuff that's new is the only stuff that's new is a chunk of stuff relating to 2 topics: object-oriented programming and graphical user interfaces and events. The object-oriented programming has been kept to the bare minimum. You've got to write some classes and make some objects. But a lot of the machinery of object-oriented programming, the inheritance and overriding and overloading and yada yada yada, isn't in the standard. If you're really confident you might do it, but it's certainly not required. That's probably not going to be too difficult, and it adds another layer to sort of the idea of scope, this idea of encapsulating stuff nicely into classes and objects. The other chunk of stuff is graphical user interfaces, building a GUI and event handling to make it work. There's nothing conceptually hard about it, but there's a lot of fiddly details. You've got to set these things up and configure them and place them on the screen and colour them and then bind them to the behaviours that make them work. Not conceptually difficult, fiddly, fiddly, fiddly. Let's have a look at the actual text of the step-ups in the standard. The new standard, which was supposed to go up on the NZQA website or wherever it goes, is the last pages of this document you've been handed. So you can see the language there. I've pulled it out onto the page in the handout, which is printed 2 up, and which really is disappointingly hard to read as printed. I didn't get time to format this nicely. So it might be easier to look at the PDF sometime, and the PDF is what I'm showing here. What I wanted to do on this 2UP page was compare the language of standards 245 and 246 with the language of standard 346, highlight the similarities and highlight the differences. And I've done that with the use of colour and fonts so that you can see what's new and what relates to the previous standards. Basically, as we go through it, and here's the achieved criteria. Designing and implementing a program that includes variables, index data structure, modular structure, details of the procedural structure of the modules. That's a compressed version of level 2 stuff. The stuff in blue, setting out comment code clearly and documenting, same as level 2. The stuff in this odd font here, testing and debugging the program to ensure that it works, same as level 2. So here's the new stuff, and I suggest you underline it because I didn't get that done in the printed version until I realised how horrible the printed version was and underlined it in the PDF. Here's the new stuff, including a working graphical user interface with different sources of event-generating components. That's poorly phrased, with different kinds of event-generating components and event handling, and using classes and objects to encapsulate data and methods. So that's the two chunks of new stuff that I mentioned just before. Write classes, make objects, write a graphical user interface. So that's achieved. Got to get that done somehow. Merit. Again, the red stuff, the blue stuff, and the light green stuff, it's all level 2. The new stuff is underlined. You've got to have the things that are well chosen now include encapsulation of the data and methods, graphical user interface, and event handling mechanisms. That stuff's got to be well chosen, and I'll try and say what that might mean on the next slide. And then excellence. All the stuff in red, blue, and the khaki green there, same kind of concepts as level 2. You can match them back to the planning standards and the programming standards on that 2UP slide. The new stuff is that among the things that have to be well structured, logically decomposed and robust and so on, is the graphical user interface and event handling design. So that's all. There's just these two new kinds of stuff interwoven into the language of the previous standard. So I hope there's reassuring continuity. I hope to assure you that the new stuff is manageable. 2 chunks of topics, manageable. Any thoughts or questions so far? Yeah.
You say things like setting up the GUI stuff and having event-driven is difficult, but there are some development tools where it's a case of you grab the button, you put it on the page, you double-click the button, and everything's done for you, and there's nothing difficult. In fact, it's way easier than things that are done with text-based programs.
Yep, and there's language in the standard. Explanatory note 6. Any code that is auto-generated by an IDE cannot be used as evidence of student code. Okay, so yeah, you can do that, and if it writes the code for you, that can be part of what you do, okay, fine, but it's not evidence that the student can use of their own work. They've got to write the code.
So effectively, you can't use that development environment because most of the code that is auto-generated, you can't actually get at that part by picking it from you.
You might use it to illustrate points, you might use it to practice, you might use it with that capacity switched off. But if that's the only tool they've got and the only way they've got it working, they do fall afoul of explanatory note 6. Pondy, I think, has a comment, and Michael, I think, has a comment.
It's a very difficult one there. Even with the drag and drop GUI interface building, the students will still have to put the action or the behavior of the button. And that is actually the critical part of the event handling there. So if all they do is drag a button and simply choose a method that gets run, then it's what Anthony said, that's auto-generated, there's not much evidence. But if they're attaching more code to that button, even if the button got drag and drop, but they were writing event handling code, what happens when they press the button? That bit of the code is evidence, which it counts to. Anthony talked about it being very fiddly, and the drag and drop make it easy. If you're trying to make nice-looking, complicated user interfaces, that's absolutely true. But I don't know if you're going to be talking later. You can make very simple user interfaces with Python, for example, and it's not that hard, as long as you don't go to fancy ones.
I've got a couple of demos at the end.
So I was more just a question, I already kind of answered it. So let me just clarify. So if you're using, say, Visual Studio, you've got a form, you drag on a button that, say, says change the background color to red. And then the student double clicks on the button, that automatically creates the click event handler, and takes you to that stub, that method stub. And the student then writes the line of code that changed the form background color to red. Is that considered? We've got a no here, we've got a...
Very grey.
Okay, we've got a very grey.
Can I just clarify, if you were to use that environment, but then created classes and methods around that, so, maybe a method which goes off and changes the colour to whatever argument you tell it, or something like that, then would that be okay? So you still use methods and some sort of objects and classes?
It's the same grey question. It's how much is done automatically and how much did the student write?
How would you go if you didn't use the wizard? In other words, if it's something the wizard would generate for you, it's not acceptable. But if it's something that a button has been created and significantly modified, so that you're actually controlling what the button does completely, then that should be quite acceptable.
Yes, that's
So
the
you're
aspect of the way Pondy described it.
Yeah. So non-wizard based code would be acceptable.
Well, all code's acceptable, but it's what counts as evidence for meeting the criteria.
Well, being the event handler criteria. So, I was just going to
We might get bogged down in this if we stay here on maybe a smaller group at the end if we're fascinated by this issue. It is going to be difficult.
We do need clarification on it by those teachers on it, I think.
Yep.
This is important.
Okay, well I can't give you official clarification, I can only give you my opinions and and like Pondy, it's a great
you're having to will help me.
Well, no, the examples that I am going to show you have got no auto-generated code in them.
Good.
Okay. So what's old and what's new, that's in detail. What do I think these step-ups mean? The same as I think they meant last time. If the program works, it's achieved. If the program works and it didn't do anything abominable, it didn't use programming elements really, really poorly, if in the language of the standards the programming elements that it used were well chosen, then it's merit. And if it's a good program, if it's well structured, if it's clear to read, if it perhaps showed some insight into the task that let them get a simple design, in the language of the standard, if it's well structured, logical, flexible and robust, then it's probably an excellence program. Now what that means in terms of code, I'm not even going to try and attempt to do this year. I tried it last year for the level 2 ones, and there's a resource there, the equivalent version of these notes that I passed out for level 2, which tried to show examples of programs at level 2 programs that met each of these kinds of criteria, or that illustrated the points. So from my webpage there you can get those level 2 notes. There's a couple of running examples, one involving a hangman game and one involving writing a checkerboard pattern, where I tried to cash out what I meant by this interpretation of how to read those step-ups. Outside the kind of quality of the program, there's two slightly tangential and more kind of quantifiable things that you can look at, which the standards emphasise. That is how well the program is commented and how well the program is tested. Now, the two languages that we write workbooks for have different strengths and weaknesses. Java has a feature called JavaTop, which would really lend itself to meeting those commenting criteria. And Python has a feature called DocTest, which really lends itself to the testing criteria. Other languages might have other strengths and weaknesses that lend themselves to these two. They're kind of outside the how good is the program, how well is it designed. They're slightly more objective, and you can get a benefit in choosing a language that supports one, other, or both of those kind of criteria. Okay, so the two new layers of stuff. The object-oriented stuff and the graphical user interface and events stuff. I like to make the analogy to a cooking recipe as an example of a good old-fashioned imperative program. A cooking recipe sets out the ingredients: cup of flour, teaspoon of cinnamon, pound of butter, and then it sets out some processes. You know, sift the dry ingredients, cream the butter or the sugar, bake until golden brown. Recipe program, data structures, algorithms. That's the good old-fashioned imperative style. That's probably what we were doing at level 12 on a small scale, year 12. Object-oriented programming has the same things, but they're broken up into logical chunks called objects. The data and only the algorithms that operate on that data should be grouped together into a class, and we make instances of that class called objects. So while in year 12 we were using object-oriented language, perhaps like Java and Python, we weren't explicitly using, we were certainly under the hood and without realising it, using objects and stuff going on in the background, but they weren't explicitly object-oriented programs. Year 13, they've got to use basic OO features, they've got to make classes and instances of them, but without a lot of the more complicated machinery of object-oriented programming. So, how might that look? What an object is just a consistent organisation of some data and some algorithms into a coherent whole. Object-oriented programming was a response to the growing complexity of programs. If we just go back to my cooking analogy, having all the data structures and all the algorithms together works fine for small teams and simple tasks, but as the teams got bigger and bigger, as we invented Google and teams of programmers like that, the complexity overwhelmed this approach. It's like, I made the analogy of this to a recipe, it's like having 10 different cooks in the kitchen, each trying to make a 3-course meal, and they're fighting over the oven and they run out of flour because there's just no control of the resources. This is like sending each cook to their own kitchen with their own resources, and if they want to borrow a cup of sugar from another kitchen, they've got to ask nicely and they get a cup of sugar. So it's a response to complexity, it's an attempt to deal with complexity, and it does that by organising data and algorithms that belong together into classes, and then we make objects from classes. An object is some part of the running program, like a class is code that we write, and from the classes we make objects. And there are two main kinds of objects, class objects and instance objects in most languages. Class objects, there's one and only one class object for each class in the program, and instance objects, we can make as many instances of that class as we want to. The class, the code that we write, and the class object in the program that represents it is kind of like a blueprint or a stamp, and it can stamp out instances of itself. So to represent this room, I might make a person class and then an instance of person for every body in the room to represent instances of the class of person. Okay, here's classes and making instance objects in both Python and Java. It may not be legible on the screen, but I hope it's legible on the copy you've got in front of you. I like, where possible, to show examples from similar languages side by side. I think if you see something once, you learn a recipe. If you see something twice, you see patterns. You see what's the same, you see what's different, and it's the pattern that you want. It's the abstraction away from any individual particular language and its syntax. Here's a class person in Python, and it's just class person, and everything inside is indented. It has a constructor method. Constructors are methods that we run to make instances, and it's got some other method. There's one piece of data in this class, it's called name, and we can set name when we call the constructor. And the name of the person might be Tom, or it might be Sue. Here's the same thing in Java. It's a class. We've got to explicitly declare the piece of data as part of the class. Here in Python it's kind of done implicitly in the constructor method. It's got a constructor method which also sets name to an input value, and it's got some other method which just prints out name. Two classes, each with two methods, each with one data field, what's called an instance variable in Python, and a data field in Java. Here we go making instances. In Python we say, I'll call my instance by the name P1, and I'll store a reference in there to a new instance object, which is made from the class person, and I send the constructor Tom, and the constructor sets the data field to Tom. And I make a second instance in the variable P2, and the name there is set to Sue. And if I call the show method on those instances, P1.show, P2.show, the show method will return my name is Tom, my name is Sue. That's it, that's a class. And I've made two instances of the class, and I program amongst the objects that it has when it runs. It will have a class object representing the class person, and two instance objects representing the instances referred to by the variables P1 and P2. And the same concepts with a bit more fiddly syntax going on in Java. Seeing the two side by side, I hope you can see the patterns, more similarities than differences, but that's all there is to making a class and making instances of it and calling methods on it with this dot notation. Name of the object, dot, what you want to do or get at in the object. Any thoughts or questions? Okay, let's carry on. So, the mechanics of it is simple. The design constraint which relates to these classes, and it's the language straight out of the standard, the design constraint is encapsulation. We're looking for good encapsulation. And there's two kinds of aspects to encapsulation. Group data and methods together logically, put the right data and the methods that operate on that data together in the same class, don't have some data here and some methods somewhere else that deal with it, group them together into classes, and keep data safe. What does that mean, and why would we need to keep data safe? The underlying assumption of object-oriented programming is that code which is inside a class is trusted. It's trusted, it's tested, it's written by the same person or the same team. They made it work. We can trust code inside the class to manage stuff inside the class properly. Stuff outside the class is bandit territory. We want to protect our data in the class from whatever other mad programmers might be doing somewhere else in the program, or indeed our class might be taken out of this program and moved to some other program completely. We want to make it impossible to break our data if that happens. So no matter what's going on elsewhere in the program, shouldn't be able to break our data inside the class. So Year 12 programs were like all in one class. All access to data was direct and simple because all the code trusted itself. Now we're going to have this layer where we can wrap data up in a class and protect it from programmers elsewhere in the program, because who knows what those folk do. So here imagine I've got my class person and it's got some data field age. And I've got an instance P1 and there are various task constraints on age. If I update age, I might want to update some other variables like years of service. I might want to do some checks. Now that age has been updated, does this person qualify to vote? Do they qualify to drive? Should the Queen send them a letter on congratulating them on reaching the age of 100? There's all sorts of checks that should surround any update of age. If in the main routine outside the class, I can just say P1 age equals something, and that happens, there's no encapsulation. I didn't enforce the other checks and the other updates that should go along with this change to age. But if I change P1.age and it happens indirectly, and all those associated changes and checks happen automatically, if the only way of changing P1.age involves invoking all these other checks and updates, then that's good encapsulation and my data has been protected. I know NovaPay has come up several times as an example, but in NovaPay, somebody is updating your hours worked and not doing the other checks that should go with it to calculate your pay correctly. If that program had been well designed and the data was encapsulated, it shouldn't be possible to change somebody's hours or job description or whatever without the right stuff happening automatically. That's encapsulation in a nutshell. Make it impossible to change data without all the right stuff happening automatically. Any questions, any thoughts? Comment up on the
This encapsulation is what you were referring to as well-designed,
Yes.
well-chosen. This is the step-up part of it.
Yes.
The core is just
The core is
wrapping
just
up
do
into
it.
classes.
Yep, the core is just do it. And the step up is have they built in these protective mechanisms? And what are the protective mechanisms? In Java, you would make data of a class private, as you'll see in the previous example, I believe I did. The data would be private, and you would access that data via special methods called get and set methods. And if you wanted to change p1.age, you would say p1.setAge and pass in a new value, and your setAge mutator method would do all those checks. This is described in the handout. Python kind of hides setters and getters behind things which we recommend you use called properties, and they have more or less the same effect. You want to change an attribute, it's hidden behind a property, and that manages these extra methods that get invoked to do all the checks and updates for you.
Lunch will be ready in about 5 minutes, so what we're going to do is maybe if you want to do another 5 minutes or so, and then we'll carry on after lunch.
I might almost be finished. I could certainly. Yeah, no, what? I'll go on after lunch. Another 5 minutes and no, I am going to be nearly finished. I'll try and be finished in 5. The other chunk of 6. Maybe Michael can speak after lunch now. So
Yeah.
Start the new session. Okay. Graphical user interfaces is the other chunk of new stuff. And there's 4 parts to building a program with a graphical user interface. At the most sort of abstract and global level, there's 4 things you've got to do. Graphical user interfaces deal with events. What happens when the user does something like moves a slider or clicks a button? 4 things you've got to set up. What is the user interface going to look like? What is the user interface going to do? How do I link the looking with the doing? How do I bind one to another? And how do I initiate event handling so that when the user clicks the button, the right actions are taken. Here again is Python and Java side by side. Here again, it's maybe too small to read up there, but you've got it on the handout. And again, notice the similarities and the minor differences. In Python, you're making widgets that represent buttons and sliders, and in Java, they call them components. In Python, we recommend the use of the tkinter package to get your graphics done. Java has the built-in AWT and swing libraries. In Java, you make an instance of the TK class to put a window on the screen, and in Java, you make an instance of the frame class to put a window on the screen. Doing. In Python, you have callback methods or functions which get triggered by events in the graphical user interface. And in Java, you make listener objects, and the listener objects have methods that respond to events. How do you link the 2 together? Python has 2 mechanisms, command for kind of high-level processed events and bind for low-level events. And in Java, we register these generators with the listeners. Very similar. Waiting for events, pretty much automatically both. In Python, we start up the main loop method on the root window, and in Java, the first time we bring up a frame on the screen, all this event handling stuff starts up in the background. So, not terribly difficult, and I'll just finish off with a couple of quick examples, which are here. So here's my first one in Java. Don't worry about this at the moment, we'll look at what it does first. 3 sliders, a graphical user interface consisting of 3 sliders, and if I move them, the background colour changes. It's a mix of red, blue, and green, 3 primary colours, or red, green, and blue. The 3 primary colours that you can make any other colour out of. So, nice simple graphical user interface, 3 sliders, changes colour. This is the application class. Looks a bit fiddly, but it's bog standard every time. You do this every time. The only thing that changes is the support class that you make an instance of. So that manages the frame, which is the window here in the operating system. And it's fiddly, but it's boilerplate, all the time the same. Here's the class that actually did the work. And it made 3 slider objects called R slider, G slider, and B slider. And it configured them to be horizontally oriented and to operate within a certain range. I have this all nicely set up, but of course the printer this is a different resolution from what I set it up for. So you add the sliders into the panel, which is visible, and you make a listener object as I described, and you register the listener object with those sliders. And then the listener object just has an event that says anytime the slider changes its state, we set the background to a new colour based on reading those 3 sliders. That's all there is to it. That's the complete program. Not horrendously difficult. Here's a similar example in Python. In Python, there's the complete program, all on one slide. If I run it, I get this graphical user interface. Only one slider this time. That slider changes the length of a horizontal red bar. There's the complete program. There's the constructor method for the class, which sets up the canvas, the drawing surface, the rectangle, which changed its width, and some elements that help us position things on the screen. And way off to the side where we can't see it, there is the binding between trouble with screen resolution. Okay. Off to one side, there's a little thing that says command equals, and it says command equals resize rectangle. So when the slider changes its state, when that scale changes its state, there's a command which binds it to that method, and that method just says redraw the rectangle with new coordinates. And that's all there is to that program. Here's the main routine, which makes the visible window and starts up the main loop, which does the event handling. That's all there is to it. Last example, and then I'm done, also from Java. This one makes a very short animation. Fortunately, run is still visible on the screen. And that just moves a red dot across the screen. Once again, the application class which makes the window is boilerplate, and the work is done here. And this uses a timer to generate an event every 10th of a millisecond, every 10 milliseconds. And that timer event is handled by a listener which adjusts the position of X on the screen and moves that object across. So once again, complete program, does a little bit of animation based on events generated from a timer. There's a few nice variations I can do with this, but I'll stop there. Anyone who's interested in looking at these examples in a little more detail might want to spare the first 5 minutes of lunch, and I can go through these. Otherwise, that's about it. It's a new standard. A lot of work, but not impossible. Not too scary, I hope.
So, the level of complexity for the program, is that sort of clear? I mean, that wouldn't be enough as a final product.
No. No. The level of the language of the standard, again, this is such a difficult thing. The language of the standard says the task must be rich enough to combine these elements. You could write a pretty simple achieved level program in this, but to demonstrate the kind of good encapsulation of design, you need a few classes and a few different elements to the graphical user interface so that you can group them logically and encapsulate them properly, and so on. So, like the use of auto-generated code, how complex is a piece of string? Be guided by the official resources released from NZQA. Is all I can say.
Anthony just said, for the achieved level, it does not have to be big. They can be achieved if they've got a button, an object, or a class defining some objects that does something that it's connected appropriately. The achieved does not have to be big. Merit and excellence, so demonstrate a bit more than that. But this gives scope for the students to start small and add and build, and that's another important part of this standard.
Okay, we're not actually going to finish there, we're going to just have lunch, and then we'll pick up a discussion afterwards. Yeah, in 2 minutes, yeah.